Hello. Good morning, good afternoon, good evening. My name is Etietop Demas Abraham. You can call me Etty. Today we're going to be talking on something interesting, an algorithm called KNearestNeighbor. There's a saying, show me your friends and I'll tell you who you are. This is one of those kind of algorithms that looks around the closest neighbors, and based on the neighbors surrounding a new object, the algorithm can classify and say that this object belongs to this class. So I'm going to show you how it works, and it is important to understand the fundamentals of how this algorithm works, and it can be implemented on Python with scikit-learn, but I'll show you simply how this is done on Google Sheets. I'll also show you how to use SQL to calculate the closest nearest neighbors in Azure. Azure. All right, let's get started. As usual, let's minimize this. Okay, I'm gonna start off with this task as we always do. However, let me explain this with a simpler example. So for instance, let's zoom in. So for instance, you have this data set, right? And you have all these products, bananas, grapes, shrimps, and they have two features, sweetness and how crisp this banana or grape is. So, right, they all have values and they're classified based on the sweetness and crispness, whether it is a fruit, protein, vegetable, right? Now, this is basically supervised, trained dataset model, right? Supervised means that we've already labeled the classes in order to teach the algorithm what is what based on the features, right? So now we have this new feature out here, bell pepper. Is it a protein? Is it a vegetable? Is it a fruit? Right? I mean, for humans, it's easy to look at it and say, "Oh, yeah, this is a vegetable." But for computers, you got to teach them. Let's quickly just graph this, and let me explain how this works graphically. Let's insert a chart. Let's do, or not a column chart. Let's do a scatter plot. Right, perfect. So you see all these points on this graph are basically objects from this data set. So bananas, this is one object, this is another object. Let's make that look, let's customize this chart and set the series to look so you can see the labels, right? And this is our new object, our bell pepper. It's at position sweetness 6 and crispness 9, which is this guy. So let me highlight this. All right, so look at this point, right? We need to classify bell pepper based on sweetness and crispness, right? In doing so, we have to compare and calculate the distance between this point and the closest neighbors. So there are this point here, there's this point here. So this is closer, this is closer. And usually there would be a limit to the number of neighbors you want to actually are evaluate, and sometimes it would be 3, like in the example we're going to do is 3. And how do you calculate this distance? So there's different ways you can go about it, but the most popular one is the Euclidean distance. Euclidean distance is quite simple. It's basically, like we have sweetness and crispness, which is the x and the y axis. X for the sweetness, y for the crispness. And the difference between x2, right, which is our new point, and x1 square, right, plus the other features, square root will give you Euclidean distance. Let me put that out here so it's clearer than just saying it. So let's say Euclidean distance, for instance. Distance, I think it's usually called D1. Right, so the formula is pretty simple. Remember, we have to calculate the distance across all the objects and take the closest three neighbors. And based on those three neighbors, we look at their classes and we will take a vote. If two out of the class for the closest neighbor is fruit, then bell pepper is going to be fruit. If two out of them is vegetable and one is fruit, then bell pepper would be vegetable. So how do you do this? So the formula is quite simple. So the square root of the difference between the distance between the new object and the neighbor, and you square that. Pretty simple, straightforward. No big deal. You have to do this for all the features, not just sweetness. You have to do this for crispness as well. So let's do that. 9 minus 1 and square. So this is the distance. We can drag and drop this across all the objects. So I'm just going to lock this in and lock C in. Right, perfect. Now, if we order this distance in an ascending mode, let's also try to make this look cleaner, right? You would see that the closest distance to, based on the Euclidean distance for bell pepper, we have if we take K as 3, right? That means the closest neighbors we are considering is 3. Then you would see that the top 3. No, what did I do? You would see that the top 3 here is the votes here is 2 for fruit and 1 for vegetable. So Euclidean distance wise, and K equals 3. Bell pepper is a fruit. However, if you increase the number of neighbors in your evaluation, let's say you get down to 5, for instance, then the closest neighbors with the highest vote would be vegetable. So, yeah. And there are other ways you can also do this calculation. There's Euclidean distance, there's the Manhattan distance, usually called D2, Manhattan. And the formula for this is also straightforward. It's the absolute value of the difference between the distance of the objects. So 6, which is our bell pepper, minus carrot, plus absolute value of the distance between the second feature and the new point. And here we go. So let's lock this down. So we fix this with lock, and we can apply this across all the other objects. Perfect. Now, we don't need this. We don't need this. If we extend our filter now, let's switch off this filter, and let's filter based on our Manhattan distance. And we get to the filter, and we sort. We would see also based on the Manhattan distance, if K is equal to 3, the vote here is that bell pepper is a fruit, right? But if K is equal to 4, then there's a lockdown, right? If K is equal to 5, then it's a vegetable. There's one more. It's called the Chebyshev. I hope I got that spelling right. All right, usually call it like D infinity. Right, so Chebyshev distance basically takes the maximum value of the absolute difference. So the formula is also pretty simple. Maximum distance of the absolute difference between the points. So the maximum when you compare both points of all your features, so absolute or second point. Let's see if this distance would, let's lock the point, will be different with K equals 3. Isn't that exciting? Let's see. All right. Let's switch up this filter and let's filter based on Chebyshev. Ascending order. And we're doing this in Excel, by the way. Right now, based on Chebyshev 2, if k equals 3, bell pepper is fruit. And if k equals 4, it's a tie. If k equals 5, it's a vegetable. If k equals 6, it's a vegetable. Right, so now you get the basics about how this works. Pretty simple, pretty straightforward. There is a calculation of the distances between a new object set, which you're comparing, right? And the closest neighbors using Euclidean distance, Manhattan, Chebyshev, and I'm sure there's some more other or distant vector matrices. Or there could be a couple of other examples, but because of time, we're going to jump into the live example. Or this other example is, for example, if you had a data set of cars with horsepower and weight and fuel efficiency, trained basically, we know the car type, sedan, sports, SUV, and we had a new point, let's say with just this data set of horsepower, weight, and fuel efficiency, what would be the car type? So similarly, we find the Euclidean distance, we find the Manhattan distance, or we find the Chebyshev distance, and we sort it and we look at the closest neighbors, whether it's 3 or 5, depending on the nature of the problem set, and then we determine by a vote. This is how KNearestNeighbors work. Let's go to our example. We're going to do this example in Microsoft Azure. And we have this table set. It's a simple one, X, Y, and class. And we need to basically look out for the new object 67 and 95, which is X and Y. So let's go to Microsoft Azure. All right. And go to experiment. And here we go. All right. So we're going to be creating a new experiment. Right. It's easy here as well in the studio. So let's enter, let's do a manual data entry. So we enter the data manually. Let's go back to the question and copy this. This is a CSV format, comma separated values. And we paste that here. Right. And we have that. Let us select our data sets from this information. So we get to the select columns. We connect the manual data to our columns, and we launch a column selector. I like to use the names filter, so I'm going to run this first so it can populate it for me. And let's go back and reselect from the names. And so ID, Y, class. So we have our X, we have our Y, we have our ID. Let me take this out and do it in order. ID, X, Y, class. Okay. What also I would like to do is edit the metadata so we can use the X1, X2 formats and Y instead of class. So it's easy for us to work with this data set. So let's do the metadata. This metadata component allows us to change the names of the fields. So let's launch. Yeah, okay, I have to do ID, X, Y, and class. All right, so I'm going to put new column names. This is going to be ID, X1, X2 is a second feature, Y is our class. Perfect. All right, so we have this, our data entered manually, and we have this. So let's use SQL transformation to select our data set and perform a transformation. And we're going to be performing the exact same transformation we did on Google Sheets. Yeah. So we want to calculate the Euclidean distance from this data set using SQL. Also, maybe we can also do the Chebyshev and the Manhattan distance. So let's get to it. So select, let's first get the ID. Let's get X1, let's get X2. Let's get the class, which is Y. Let's also get, so now we need to do the square root. Remember the formula? So power of the new point is 67 and 95. So 67 minus x1, and we're raising that to the power of 2. We're adding that to second feature again, which is 95, I think. Let's double check that's correct. 95 minus the second feature, x2. We're doing this to the power of 2. Let's do this as Euclidean distance. Let's quickly also do the Manhattan distance, which is the absolute value of points. So new point is 67 minus x1 plus absolute value of the second point is 95 minus x2 as Manhattan distance. Do we have time for the third one? Let's also do the Chebyshev, which is the maximum of the difference of the absolute values between the points 67 and x1 and 95. I hope I'm not making any mistakes here. And x2 as Chebyshev. We're getting this right. So looking good from T1. T1 is the default name of the table in our Azure. Okay, so we're getting this from T1, and let's order by Euclidean distance so that we can see and set the limit. Order by, let's do this ascending, limits to 3. Yeah, maybe there'll be a mistake. We don't know. Let's run this. Okay. So our studio is executing the commands, applying the transformation. Ooh, we run it in 1, and let's visualize the result. Wow, as you can see, let's look at the question again. Enter the distance from the new object with coordinates 67, 95 to the nearest neighbor using Euclidean distance. So the nearest neighbor is 14, right? No, 14 is Chebyshev. Manhattan, we're talking about Euclidean 14.03. And that's correct. Enter the ID of the 3 nearest points to 67 and 95 for Euclidean distance. We got that as well. The 3 nearest points is 8, 10, and 3. And that looks absolutely right. Enter a class for the new object with coordinates, given that k is equal to 3 using Euclidean distance. Let's write a small query for that vote. Let's do another SQL. I mean, we can already see that the answer visually is the votes for y is 1. We have two ones for y and 0. So the class for y is gonna be 1. But let's just do this in a query so we are not making any mistakes. So we create another query point, and let's link this and just select y and count y from T1 order group. Let's group by y, order by, let's do this count as votes, so we can order by votes. Let's order by votes. Yep. All right, let's run this. Okay, studio is running. All right, let's visualize the results for the vote. And as you can see, 2 votes for 1 and 1 vote for 0. So our class is what? 1. So there we go. And then you see the second question is enter the distance from new object with coordinates 67 and 5 to the nearest neighbor using Manhattan distance. So let's see. Manhattan distance. We'll have to tweak the query a little bit. Let's do that. All right. So the Manhattan distance, let's, instead of ordering by, no, that's not the right one. Okay, that's the right one. Instead of ordering by Euclidean distance, we'll order by Manhattan distance. So copy this, replace this, and run the code again. While it's running, let's review the question. It says the distance, nearest neighbor using Manhattan distance, the closest one. Let's see. So we go to our result set. Right, results, visualize. And we can see that based on Manhattan distance, the closest neighbor is with a distance of 15. And that is absolutely correct. Enter the ID of the 3 nearest points to 67 and 95. The 3 nearest points is already there, 8, 9, and 10. We can see 8, 9, and 10. And based on the Manhattan distance and k equals 3, what is the class of the object? So we can also look at that and judge for ourselves. That's 1, y is equal to 1 just appeared once and 0 twice. So we will classify this as 0. But just to be sure, you can also look at the results set from our query. And you would see we have 2 votes for 0 and 1 vote for 1, which gets us to the answer of 0. That is all. Thanks for your time. I hope you enjoyed this video. Have a beautiful day.